Interfacing gyro sensor. What is gyroscope? Gyroscopes are manufactured on the basis of MEMS technology similar to accelerometers. Gyroscope provide a relative angle of tilt in all the three axes. If a body is tilted at an angle, gyroscopes can give the angle of tilt of the object with respect to the three axes. The terminologies for these three tilt values are referred as roll, pitch, and yaw axis respectively. The same is presented in front of you as a pictorial representation for easier understanding. Applications of gyroscope. Gyroscopes have a vast market in today's world. They are used in many consumer electronic goods such as washing machines, mobile phones, and navigation systems used in the vehicles. In fully automatic washing machines, when the load drum rotates and if all the clothes get accumulated on one side, it creates an unbalanced load of motor and starts to produce vibration and noise. To avoid this, gyroscopes can be implemented for even spread of the cloths. Gyroscopes are widely used in navigation systems because of their sensitivity towards the tilt and change in angular velocities. Moreover, as their manufacturing is based on MEMS, their size can be scaled to the micro level. We have presented the electronic gyroscopes and mechanical gyroscopes for your reference in front of you. Let's go with the interfacing of MPU 6050 with Arduino. MPU 6050 is an inertial measurement unit, we call it IMU normally, with 6 degrees of freedom that works on I2C protocol, which means that it outputs 6 values, 3 values from accelerometer and 3 values from gyroscope sensor. Let us take a look at the type of the pins which are present in MPU 6050. It has got VCC, which is the power line for the board, ground line for the board, SCL, I2C serial clock line it is, SDA, it is referred as the serial data line, AD0 is the address select line, INT is the interrupt pin, and the same has been presented in front of you to get a better and a quicker understanding. Let's go with the further learning in the interfacing part. In the MPU 6050 sensor, we will be using only the VCC, ground, AD0, SDA and SCL pins. The remaining pins can be left as such without being used. The connections are represented pictorially in front of you, as well as a table is presented for your quicker reference where with the values shown in the Arduino are to be connected to the appropriate pins in the MPU 6050. VCC of Arduino should go to VCC of MPU 6050, ground to ground, AD0 to ground, A4 to SDA and A5 to SCL. The same has been represented here and one can have a quick verification on these connections as well. As already mentioned, the MPU 6050 uses I2C protocol and we will be using SDA and SCL pins. To access the I2C library on Arduino, we will be using wire.h library, which provides all the necessary communication commands for the I2C. We need to begin the I2C communication by using wire.begin and serial communication by using serial.begin commands. The same has been presented as the code here. Include wire.h is the header file to be used for I2C protocol. Long is the data type for gyro X, gyro Y and gyro Z. This is to store the raw gyro values. Float ROTX, ROTY, ROTZ. This is to store the processed gyro values. And in the setup, we have got the baud rate setup here and we are using wire.begin to start the I2C while library. And setup MPU is the custom function used to set up MPU 6050. The setup MPU function does all the setup process for the MPU 6050 such as initialization of the transmission and I2C addressing. Wire.begin transmission expects the binary address of I2C sensor as an argument and sends the communication initialization bits. Once they are acknowledged by the MPU 6050, communication can be started between the sensor and the microcontroller over the I2C protocol. Let's go ahead with the code for setup MPU. Wire.begin transmission in the brackets 0B11010000 is used for beginning the transmission between the microcontroller and the gyro with 0B11010000 being the I2C address of the gyro. Wire.write is used for accessing and writing on a particular register. Wire.end transmission is used for ending the transmission. Wire.write, it is a command to write data onto I2C. Remember, wire.write is a command to write data onto the I2C. We first write the hexadecimal value 0x6b. Hexadecimal is a representation of a number which is most commonly used in microcontrollers, and the value 0x6b indicates the power register address. Every microcontroller is sent to power saving mode by default to save the power. So, in order to start communication, we must send an interrupt that says, hey, get ready for communication. Initially, it would be like in sleeping mode or in the power saving mode. When you give wire.write with this value, then it will get ready for the transmission. Once the sensor wakes up, we can request it for the data that we need. So, we must first send the I2C address of the gyro sensor configuration, which is 0x1b. One can find these addresses in the datasheet and nothing to bother about it. We will set the full scale output configuration of the sensor, which is the maximum value that the sensor can output. There are different full scales, 250 degrees, 500 degrees, etc. The code is already explained and the same is presented in front of you. The 0x43 hexadecimal number is returned on the MPU 6050 for starting the gyro register. Wire.request from is used to request the data from the registers. Gyro X, Gyro Y, and Gyro Z are used to store the register readings of the gyro sensor using wire.read. Now we are going through the code. Record gyro registers is the method, and in that we have got the begin transmission with the I2C address, and we are writing 0x43, which is nothing but the starting register for the gyro readings, and we end transmission. Wire.request from 0B11B0100, 6 is used for requesting 6 registers starting from 43. And we can see that we can store the first 2 bytes into gyro X, the second 2 bytes, the middle bytes into gyro Y, and the last 2 into gyro C. That's it. It's very simple for anybody to understand. The function process gyro data is used to process the raw output gyro data from the sensor. We need to divide the obtained value with 131 to obtain correct angular velocities. The division is done with a float data type. So the division used to be done with 131.0 instead of 131. Remember this point. The function print data is used to print the process data. The record gyro registers method and print data are used in the void loop for starting the communication through I2C and printing the gyro data. The same has been presented as the code here. Process gyro data has got ROTX, ROTY, and ROTZ, and they are divided by 131 respectively. This is for printing, and you could see that GX and ROTX, GY, ROTY, GZ, ROTZ. The values are printed, and in the loop, we record gyro registers. We use the record gyro registers to record the gyro values from MPU, and then we print the data, and delay is for stabilizing the MPU. Thank you very much. It is time for us to go ahead with the demo for the interfacing of the gyroscope with the Arduino. We'll go ahead step by step with the demonstration process, which you can correlate with the theoretical explanation which we have given. Make the connections as we have already explained you in the tutorial. And please make sure that the connections are VCC and ground from the Arduino to be connected to the VCC and ground of the sensor. Similarly, SDA and SCL to be connected with the SDA and SCL of the sensor, and AD0 to be connected with the ground of Arduino. Do not forget that, and that's a very important step. And the code is already explained. Just copy paste the code here, select the appropriate board, select the COM port properly, and then go ahead with the uploading. The compilation happens and then the uploading proceeds. Once the uploading is all done, you can open your serial monitor to see the values. Now I'm opening the serial monitor, and you could see that the values are all arriving for X, Y, and Z. The values are almost constant because we have not moved the gyroscope anywhere. And now when we move it, you can see that the values are changing rapidly. This is how it works. And The most important point to remember is keep the gyro in a flat surface, otherwise it might not give you the accurate output. Thank you.